Hello, Professor. I'm Keerthi Gadila. Today I'm going to talk about the topic using Excel Solver to develop a cost-saving material allocation strategy for infrastructure procurement. In introduction, we have proper acquisition of infrastructure materials is crucial for efficient delivery. However, current procurement practices often fall short. This research proposes a solution. Cost and time consuming procurement practices, environmentally harmful and unsustainable methods, inefficient material allocation and management. The main objectives are the following objectives are said to be accomplished through this research initiative is develop a cost efficient material allocation framework, leverage linear programming for resource distribution, enhance decision making through data driven insights, integrate sustainability in material allocation, evaluate economic and operational impacts. This is a literature review. In literature review, we have from the supply chain management practices influence transport infrastructure projects performance and supply chain management effectiveness impacts construction and transport project success. Proposed framework integrates dynamic material data into linear programming optimization. Proposed material defines efficient assembly sources strategies for automotive OEMs. Compare various production configurations for multi-process stamped assemblies. The literature review underscores the need for the efficient and sustainable infrastructure procurement practices and highlight the potential of innovative technologies and optimization models to address these challenges. In methodology, we have a research approach, mixed research approach, integration of quality and quantitative approach, exploration of issues related to material distribution environment. In the in the picture, you can see the theory, hypothesis, data, and the pattern, how it revolves around the qualitative mixed methods and quantitative mixed methods. In the model development, we have linear programming model Excel solver. The main components are objective function, decision variables, constraint, and solving methods. In the data, the key variables are companies from companies 1 to companies 5, and the warehouses are warehouse 1, warehouse 2, warehouse 3. The warehouse inventory levels, the table displays the available inventory levels of three warehouses. In the first warehouse, we have available inventory of 66,000, and in the second warehouse, we have 50,000. In the third warehouse, we have 70,000. From the pre-unit cost comparison, in dollars of material supplied by three different warehouses to the five companies, we have in the first warehouse the company 1 has 3.26, company 2 has 9.31, company 3 has 4.49, and company 4 has 9.96, and company 5 has 8.61 and following. And warehouse 2, warehouse 3, and for the company values, company 1, 2, 3, 4, 5 are given below. This is per unit cost comparison across companies and warehouses. Order quantity of each company is required by quantities required by each company for the different five companies. The order quantity of each company is like for the first company it's 14,000, second company 35,000, third company 76,000, fourth company 36,000, and fifth company is 12,000. Setting up Excel solver. Objective function. The main function is to minimize the cost while ensuring optimal research utilization. And in the variable cells, decision variables for distributing orders across warehouses and companies. The total constraints are total orders, maximum order quantities, and inventory levels. In the analysis, we have the main objective function is to minimize the sum of the product per unit cost for each company at each warehouse and the corresponding decision variables. The equation is sum of per unit cost into decision variable. In the results, we have the total optimized solution results in a minimized cost is $7,90,520. The optimization analysis using Excel solver successfully minimized overall procurement expenses while ensuring the fulfillment of specified ordered quantities. The minimized cost is given below. And the warehouse 1 and the warehouse 3 and has the maximum inventory consumption profile. That means the utilization of overall available warehouse capacity Where warehouse 2 depicted lack of optimal usage of available stock and as shown by the excess inventory. You can see the graph difference in the right below available its availability versus used inventory of each warehouse. The conclusion, we have linear optimization strategies can improve infrastructure procurement by overcoming inefficiencies over costs and delays. Integrating sustainability criteria and dynamic variables enhances resource distribution efficiency. Future research Future research will focus on refining optimization models and incorporating AI and real-time data processing. Thank you.